students. I'm going to talk you through the activity that is on page 23 through page 25 in your Unit 5 packet. So remember, that's the packet that looks like this with Baby Yoda on the front. For this activity, we're going to explore Newton's second law, and the purpose of this activity is to show how net force chases the acceleration of an object. And so one thing to think about is in this lab, we're going to remove the force of friction. So things are going to behave a little bit differently than we expect to see them behave in real life. The instructions on this lab are written very explicitly, so you should be able to complete this on your own, but I'm making this video just to help you guys figure things out. So let's get started. Okay, so I'm going to start by typing in the URL from page 23 where it says go to. There's the URL. And then it's going to load the website with the simulation. We want to click on the acceleration simulation. And so when I click on this, it's going to take me here to this view, and I'm going to start by following the directions, reducing the friction to none and no friction in the simulation. And then I'm going to check all these boxes over here so that I can see the value of the masses, the speed, the sum of all forces, the values for these things, as well as the acceleration that's occurring. The next thing I'm going to do for number 1, I'm going to come down here to this applied force slider, and I'm going to click and hold the slider in place for a bit. Okay, so we should be done with part 1 and answer through question 3. So now we're going to do 2 experiments. So the first experiment we're going to do is we're going to look at how net force affects the acceleration. So we're going to change net force, and then we're going to observe the effect that has on an acceleration. So you should be able to figure out which would be the independent and which would be the dependent variable based on that. When we're done with that experiment, we're also going to do we're going to do a second experiment to see how changing the mass affects acceleration. So I'm going to show how to do each of these 2 things right now, and then you guys can do it and collect your own data for your own net forces. So first, before I do anything new in my simulation, I'm going to go ahead and click this orange reset button so that I can just make sure that everything is back to where it's supposed to be. So now I'm going to go ahead and get my friction back down to 0, put all of my numbers and everything back on so I can see things. And now I'm going to start choosing some different forces. So I'm going to apply a net force of, let's say, 5 newtons. So we'll do, or 50 newtons. Let's do 50 newtons. So I'm applying a force of 50 newtons, and then I'm going to notice what the acceleration is right here. So it's 1 meter per second squared. Cool. So now I'm going to come over here. I've created a spreadsheet. You guys will have to make your own Google Sheet. I'm going to go ahead and type my name in the corner. So you guys can type your name in the corner of your Google Sheet so that I know it's yours. And then I've made a table. You guys are going to want to make a little table for each of these 2 experiments. And I put my units in the heading of my table. And the nice thing about that is that I can put my units here in the heading, which means I don't need to put them in the boxes individually. So that way it'll be really easy for Google to see what's a number, and it'll make it easier for Google to graph. So my first trial, I did 50 newtons, and the acceleration was 1 meter per second squared. You guys can then go ahead and repeat this with multiple trials. And then, so I'm just going to make up numbers. Don't steal these numbers because they'll be wrong. So just making up some numbers. This is not at all the way it would actually be expected to come out, but I'm just making some numbers. And then I can highlight these, and I can click the Chart Wizard button, Insert Chart, and I want Google to make a scatter chart for me. And you guys will have to fix up the headings, make sure that the axis labels are good, make sure it has a good title, and you want to make sure that your minimum on your y-axis starts at 0. Sometimes Google will choose something that doesn't make sense. Ideally, your x-axis would also start at 0. So if Google isn't doing that automatically, you may want to change it. Okay, so I'm going to do that for net force versus acceleration. Get rid of those fake numbers. And then I'm going to do the same thing for mass versus acceleration. I'm going to refresh this, turn off friction, check all my boxes so I can get all my values. And I'm going to start playing around to see how mass affects acceleration. So in this case, I'm going to keep the applied force constant. So I'll just do 1 Newton of applied force. And so I see I've got an acceleration of 0.02 meters per second squared. In this experiment, I'm not changing the applied force. That's going to be constant. Maybe I'll do 10 newtons so that I see something. So I'll do 10 newtons of applied force. And I can see my acceleration. And then I'm going to start playing with the mass. So first I'm doing 50 kilograms. Now let's try 80 kilograms at 10 newtons and see what the acceleration is. Now let's try 200 kilograms at 10 newtons. So I'm putting a refrigerator. So now I've got a 280 kilograms and my acceleration is 0.04. So I'm going to come over here. And in my mass table, I'll put in my mass. Notice I don't need to put units. And then I can put in my acceleration. So that was 0.04 meters per second squared. I'm not going to put in units so that it's easy for Google to graph. And I'm going to do a bunch of different combinations of things to get several different masses and then record their accelerations and make a graph. So I can put the girl on top of here, and that's a different mass. I can take the fridge off but keep the girl, and that's a different mass. That's 120 kilograms. I can have the girl hold up this big old bucket, and now it's 220 kilograms. So there's lots of ways to get different mass combinations.
Hey, here's some rat comment like I promised. This is Theo in my lap. Theo is my oldest rat. He is over 3 years old. Rat's typical lifespan is like 2.5 years. It's kind of strange for a rat to live this long. He's a very, very good boy. This is Theo. Hi, Theo. Hey. So he just likes to cuddle these days, but he also likes to eat baby food. I'll give him a little baby food as a treat. There you go. Yeah, he's a good boy. There you go. Rat content. New rats tomorrow.